Statistics and probability.
Good morning. Welcome to our subject, Statistics and Probability. Today, we will be dealing with hypothesis testing in one sample case, comparing the population means using z-test. Let's start with activity 1. We will review the concept in solving for mean. Read the problem and solve the mean. In Amihan's backyard, there are 6 trees whose measurements she records as 4.26 meters, 2.13 meters, 2.44 meters, 3.05 meters, 2.74 meters, and 2.29 meters. Determine the mean height of the trees. Number 2. Juan jogs every day in the park. He runs 5 kilometers on Monday, 4.8 kilometers on Tuesday, 5.3 kilometers on Wednesday, 5.1 kilometers on Thursday, 4.6 kilometers on Friday, 5 kilometers on Saturday, and 4.9 kilometers on Sunday. Find the mean distance covered by Juan. Pause this video for a while and answer the activity.
A few moments later.
Welcome back. Are you done answering? Let us now reveal the answers. For number 1, the answer is 2.82 meters. For number 2, the answer is 4.96 kilometers. Excellent, you got the 2 correctly. Let us now talk about hypothesis testing. Hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding a population parameter. There are 6 steps in doing hypothesis testing. First is stating the null and alternative hypothesis. Second is identifying the level of significance. Next is determining the appropriate test statistic. Fourth one is finding the rejection region. Fifth one is computing of test statistic. And lastly is making of decision. Let us now discuss one-sample z-test. The one-sample z-test is a statistical hypothesis test used to determine whether an unknown population mean is different from a specific value. The formula for this is z is equal to the sample mean minus the population mean all over the standard population or standard deviation population, or could have S, the standard deviation of sample, all over the square root of the sample size n. This is used for n which is greater than 30 and a variance is known. Let's have an example of hypothesis testing for one sample z-test. Juan Kugi, an owner of a shopping mall, claims that the mean income of the families within 4 kilometers of proposed location of a mall exceeds 15,900 pesos. At 0.05 level of significance, what can he conclude if the mean income of a random sample of 60 families living within 4 kilometers of the proposed location of the mall is 16,024 pesos and standard deviation is 763 pesos? Step 1. The null hypothesis is the salary of the families within 4 kilometers of the proposed location of the mall is 15,900 pesos. In symbols, our population mean should be equal to 15,900. Alternative hypothesis, the salary of the families living 4 kilometers from the proposed location of the mall is greater than 15,900 pesos. In symbol, our population mean is greater than 15,900 and it is directional because of the symbol greater. Step 2, as stated, the level of significance alpha is equal to 0.05. Step 3, Z-test for one sample case. Step 4. Since our sample size n is greater than 30 and our alternative hypothesis is directional and the level of significance is 0.05, the critical value is 1.645. This means that if the computed z is greater than 1.645, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. Computing the value of z, wherein z is equal to the sample mean minus population mean over standard deviation divided by the square root of the sample size n. Our given here, we have the sample mean is 16,024, population mean is 15,900, the standard deviation is 763, and our sample size is 16. So z is equal to, substitute the values, 16,024 minus 15,900 all over 763 divided by the square root of 60. So our z here equals 124 in our numerator because 16,024 minus 15,900 is 124. And for our denominator, 763 divided by 7.746. The 7.746 comes from the square root of 60 because the square root of 60 is 7.746. Moving on, our z is equal to 124 over 98.5025. The 98.5025 comes from 763 divided by 7.746. So, using our calculator, we can simplify our z, which is equal to 1.26. Step 6, our making of decision. Since the computed value of z is 1.26, which is less than our 1.645, the null hypothesis is accepted. Therefore, the income of the families within the 4 kilometers of proposed location of the mall does not exceed 15,900 pesos. The claim of 1 is not correct. Our second example of one sample z-test comparing of means. Norman suspects that the average amount of time spent by his classmates in studying their course per week is less than 120 minutes. He surveys a random sample of 36 students in their class and found out that the average time spent for studying is 105 minutes with a standard deviation of 30 minutes. At 0.02 level of significance, what can Norman conclude? Step 1. The null hypothesis is the number of minutes spent in studying is 120 minutes. So in symbol, our population mean is 120. Our alternative hypothesis is the number of minutes spent in studying is less than 120 minutes. In symbol, our population mean is less than 120 and it is directional because of the symbol less than. Step 2, as stated, our alpha is 0.02. Step 3, z-test for one sample case. Step 4, since our sample size n is greater than 30 and our alternative hypothesis is directional and our alpha is 0.02, the critical value is negative 2.055. This means that if the computed z is less than negative 2.055, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. The formula for z is equal to the sample mean minus the population mean all over standard deviation divided by the square root of the sample size n. Given our sample mean is 105, our population mean is 120, our S is, or our standard deviation is 30, and our sample size is 36. Z is equal to, by substituting the values of the given to the formula, 105 minus 120 all over 30 divided by the square root of 36. And we have here Z equals negative 15. This negative 15 is the difference of 105 and 120. All over 30 over 6. And 6 here is the square root of 36. This becomes Z is equal to negative 15 over 5. The 5 here comes from the quotient of 30 divided by 6, which is 5. So negative 15 over 5 is negative 3. Step 6. Since the computed value of Z is negative 3, which is less than negative 2.055, the null hypothesis is rejected. Therefore, the number of hours spent in studying is less than 120 minutes. Norman is right. It's now your turn to answer. Read the problem and conduct hypothesis testing. The owner of a company that sells a particular tempura claims that the average capacity of a small pack is 250 milligrams. A random sample of 60 small packs of tempura have a mean mass of 245 milligram and a standard deviation of 2.5 milligram. At 0.05 level of significance, is there a sufficient evidence to support the claim of the owner? Pause this video and answer the problem.
A few moments later.
Let us now reveal the answers. Step 1. The null hypothesis is the small pack of tempura has a capacity of 250 milligrams. So in symbol, hypothesized mean is equal to 250. And our alternative hypothesis, the small pack of tempura has a capacity which is not 250 milligrams. In symbol, our hypothesized mean or population mean is not equal to 250. And it is non-directional because of the symbol not equal to. And step 2, our alpha is 0.05. And step 3, z-test for one sample case. Step 4. Since n is greater than 30 and our alternative hypothesis is non-directional and alpha is 0.05, the critical values are positive and negative 1.96. This means that if the computed z is greater than 1.96 or less than negative 1.96, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. Computation of z, wherein z is equal to sample mean minus the hypothesized mean or population mean all over the standard deviation divided by the square root of the sample size n. Given that our sample mean is 245 and hypothesized mean is 250 and our standard deviation is 2.5 and our sample size is 60. So z is equal to 245 minus 250 all over 2.5 divided by the square root of 60. So then z is equal to negative 5 all over 2.5 divided by 7.746. And z is equal to negative 5 divided by 0.3227, which is equal to negative 15.49. Step 6. Making decision. Since the computed value of z is negative 15.49, which is less than negative 2.055, the null hypothesis is rejected. Therefore, the capacity of small pack of tempura is not 250 milligrams. The claim of the owner is wrong. This further suggests that the small pack of tempura has a capacity of less than 250 milligrams. If you have some suggestions, comments, and queries regarding our topic, just give your thoughts under comment section and directly ask me through Messenger. Thank you. See you next topic.